So this is our third problem, and in our problem we have a 1050 kilogram sports car which is moving westbound at 15 meters per second and on a level road where it collided with a 6,320 kilogram truck that is driving on east on the same road at the speed of 10 meters per second. The two vehicles remained locked together after the collision. So you are going to find what is the final velocity, both the magnitude and direction of the two vehicles just after the collision, and what must be the speed that the truck should have so that after the collision they are both stopped. So this problem requires a little bit of imagination, more imagination compared to the previous one. So I have pre-illustrated the sketch of the problem here, where A, as you can see, this is moving. If I define my direction to be, this one is east, this one is west, and this is north and south. My A, which is just my 1050 kilogram, is referring to my sports car because that is moving towards the west at 15 meters per second. Now, the one that I denoted as A is the 6,320 kilogram, and this is the truck moving eastward at 10 meters per second. So it's a matter of labeling which one is A, which one is B, so that you won't be confused at the end. Now also you have to take note that since the truck moves towards the east, so it has a positive sign, and the sports car moves towards the west, it must have this negative sign. Otherwise, if you have not indicated that properly, you will not arrive at the correct answer. Now, ideally, as I've said in class, the ideal thing is to sketch what happens after collision. But in this case, the thing that we need to note is after collision, the final velocities of the final velocity of sports car A is just equal to the velocity final of the truck, which we denoted as A. So this is one of the things that you should note about the final collision situation. So that means to say if I encounter these two quantities, the this is not A, final BF and AF, I will just call them all together as large V without a subscript. So that means the same thing for both. So in this case, we will try to answer again these two guiding questions. What is the type of collision exhibited in the problem? So since they are locked together after the collision, that means to say they move at the same velocity. This is exactly completely inelastic collision. It should be completely inelastic collision. Now in these types of collision, there is only one quantity that is conserved, and that is P is conserved, but the kinetic energy is not conserved in this case. So that means to say that since we only have momentum as a conserved quantity, we will be using this, we will be setting up equation for momentum, and we will be using that for the entire solution. So I guess we are now ready to solve the problem. So I'm just going to write here, from the conservation of momentum, I'm going to set up an equation. From the conservation of momentum, so from the conservation of momentum, I have the fact that momentum before collision, it must be just equal to the momentum after collision. All right. So before collision, I have, this will be broken down into the momentum of A initial, that means to say before the collision, or that mean the same thing, plus the momentum of B initial, that must be equal to the momentum of ball A F, indicating final or after collision, plus the momentum of B after collision, BF. So from there, we already knew what the equation of momentum is, so I'm just going to break down that into its equation. And be careful to take special heed on the subscript. So this is MA VAI plus PBI will just be mass B VBI is equal to PAF, final momentum of A after collision, is just M sub A. VF, okay, sorry, it should be VAF. VAF plus the mass of B VBF. All right, so we are now we are able to create the equation. But then again, if you notice, in this case, as I've said earlier, the problem clearly states, and I will highlight that here, that the two vehicles remained locked together after collision. So as I've said earlier, that implies that the velocities final of B, which stands for the truck, and A, which stands for the sports cars, remain the same. So I will just note that as my V without any subscript. So that means to say this term here and these terms are equal, as I've said. So I will just replace that with V. So I would do the least path because I'm feeling lazy to do that. So I'm just copying that one and replace this with V. This one also is replaced by V. And I'm hoping you do realize that on part A of the problem, you are actually asked or tasked to find for this velocity. So the velocity that we are talking is the final velocity, or simply V of both A and B. So going back here, what I'm going to do is factor out V on the other side of the equation. So I'm just going to copy the left-hand side of the equation and factor out V over here, and I am left with the mass A plus mass B. All right. Now, upon inspection, as we often do in our class, so mass A is something that you know, VAI is given, mass B, VBI also is given, V is something that we don't know, MA is given, so is mass B. So we have one equation, one unknown, so we don't have any problem at all. So that means to say that I can solve this equation directly without the need of other equation. And I can accomplish that by dividing both sides by MA plus MB so that I could isolate the unknown equation. MA plus MB. And clearly, as you can see, this term would cancel out, leaving behind only what we are looking for, which is the velocity V. All right. So I'm just going to rearrange the placement by having V written first on the left-hand side. So V is equal to MA, VAI plus the mass of B, VBI, and everything is divided by mass of A plus the mass of B. So from here, we are just going to substitute the equations by its the value of the variable. So mass of A, as you can see on the screen, it's 1,050 kilograms. The VAI, meaning the velocity of the sports car, is 10 meters per second, plus mass of B, it's 6,320 kilograms, so 6,320 kilograms. And then the velocity of BI initial, or the sports car initial, it's moving towards the east, right? East, 10 meters. Okay, sorry, I actually made a mistake here. It's 10 meters per second. However, the VAI is negative 15 meters per second. So imagine if I haven't noticed that mistake, then I would be arriving at the wrong answer. So it should be negative 15. And you just have to add MA. MA is 1,050 kilograms plus mass B, which is just 6,320 kilograms. Alright, so that means to say that you can now just plug in the values in your calculator and you arrive at an answer of 6.44 or approximately 6.44 meters per second. And I would like to emphasize that the sign, although it's not really necessary to put plus in this case because it's assumed to be positive, but I would just like to emphasize that it's positive with the implication that that is moving towards east. Because in the first place, I noted here initially that those measurements moving towards east or values moving towards east has or they have positive values. And so is the implication of this value over here. Just going to put that. Okay. So for the second part of the problem, so part B, it asks for the at what speed or velocity, since we are moving on a straight line motion, at what speed should the truck have been moving so that it and the car are both stopped in the collision? So the very first thing that you need to understand in solving for this one is this is telling you that, if I'm going to rephrase that, it's just telling you that what must be the initial velocity of the truck, and take note, I'm going to create a variable out of that. Now, your truck here is mass B, so that means to say this is just looking for what must be the initial velocity, the VBI of the truck, such that after collision, so that means to say you just have to analyze clear the problem. The final velocities, and when I say the final velocities, I am referring to both the truck and the sports car. The final velocities, or the VA final, is equal to 0, and so is the BV final. So both of them are actually at a halt, so that both stop in the collision. Alright, so this is just one of the thing that is being asked in the problem, and that is how you should approach it. You have to analyze the problem. Now, of course, the only conserved quantity is momentum, so the only equation that you will use is still the same equation as above. Right, no, I'm just going to copy this one because, as I've said, they are just the same set of equation, or same equation that we are going to use. Alright, so from here, if you try to look into this equation, I'm going to highlight it with red, the one that you are looking for. You are looking for the VBI, right? VBI, as you can see here. Now, what you are going to do is to simplify this equation by simply realizing the fact that VAF now is 0, and so is VBF, because of the fact that you are looking for VBI such that when they collided, this quantity VBF and VAF tends to 0, or they will stop at the collision. So that means to say then that I have a very simple equation. What I have is just MA VAI plus MB VBI. And everything is just equal to 0. And I am looking for this VBI. So to do that, what I'm going to do is I will, what's this? Like transpose this term to the other side. So I have MB VBI is just equal to negative of MA VAI. So to get just VBI, I'm going to divide both sides by the MB. So clearly, we have a simpler equation. One equation, one unknown, so that's a very good thing in algebra. I'm hoping you recall that discussion on the systems of equation, that is ideal. So mass of A is just negative 1050 kilograms, because this is referring to the sports car. Mass of no, velocity of A, it's moving towards the west at negative 15 meters per second, or it's actually moving towards the west. That means you have negative at 15 meters per second, just to be clear. And you divide that by the mass of B, which is the truck, at 6,320 kilograms. So at the inspection of the units, it's clearly, this one would cancel out. So you have meters per second, and that is the unit of velocity. So yeah, we're onto a right track here. So the VBI then is just approximately equal to 2.49 meters per second. And again, I will put a heavy emphasis on the plus over there, indicating that this is, or the car must be moving towards east. Okay.